going to be talking about the basic rules of XML. We'll start off by talking about the contents of XML files, where we'll discuss the types of content that you'll find in XML data. Then we'll talk about proper XML syntax, things like nesting rules, how attributes work, and other things you need to know to make sure that your XML files parse properly. Then we'll talk about how to make valid XML documents, and this is something that we'll revisit when we talk about document type definitions and XML schema. Finally, we'll wrap up with a discussion of XML namespaces, which provide a way for you to include XML data from different sources and avoid collisions with other tag names when you do so. All right, let's start off by talking about the contents of XML files. There are about a half dozen or so types of XML content that you'll run into when working with XML data. There's the XML document declaration, there's elements and attributes, comments, character data, processing instructions, and entity references. So in this movie, I'm going to give an overview of each one of these. The document declaration looks like this. It's an opening bracket with a question mark, followed by the letters XML, and then a version, an encoding, and then an optional standalone declaration. Now, the document declaration is technically optional, though the W3C recommends it if you're going to be using XML data. But you can make XML documents that don't include this. I don't recommend it though. It's always a good idea to have the document declaration. It identifies the file as an XML document and provides a place for the encoding and standalone attributes. It has to be at the very beginning of the XML data. You can't even have white space before it. The encoding attribute defaults to UTF-8 if you don't include it, but it's a good idea to include it, and if you decide to use a character set other than UTF-8, like Unicode UTF-16 for example, this is where you put that declaration. The standalone attribute identifies whether or not the document stands by itself or depends on something else. If it requires other data, then you should say standalone equals no. Otherwise, if the XML data is complete by itself, set it to yes. Okay, let's talk about XML elements, which are sometimes known as tags. And if you've worked with HTML, these will look entirely familiar to you. Elements must have valid names. They can begin with an underscore or a letter, then followed by letters, digits, periods, hyphens, more underscores. They can't use the string XML in any case combination because the W3C reserves that. So for example, some valid tag names look like this. I can have underscore with capital E and then element 1. I can have my element with a period. I can mix and match hyphens and underscores. Some examples of invalid tag names are here. So for example, one tag. You can't begin with a number. You can't have invalid characters in the name like hash symbols and ampersands. You can't use the letters XML because those are reserved. Attributes in XML work the same way that they do in HTML. They're specified on opening element tags only. They have to start with a letter or an underscore, and again, they can be followed by digits, letters, hyphens, periods, and underscores. And just like tag names, attributes that begin with XML are reserved. Attributes appear only once on a given element. You can't have the same attribute name over and over again. All right, let's talk about comments. Comments are intended to embed information inside XML data that are readable by humans. They're kind of like comments in JavaScript or other programming languages. They don't actually affect the document data, they're just there for people to read them. They're defined with an opening angle bracket, followed by an exclamation point and 2 dashes, and then end with 2 dashes and a closing angle bracket, again, just like in HTML. They can go pretty much anywhere except inside element brackets and before the document declaration. This is an example of an invalid comment because it's inside the opening element tag. But this is okay. You can put comments inside of elements. Character data sections are specified using C data. They're part of the document, but the contents of C data sections are not parsed by the XML parser, and this is important. When the parser comes across a C data section, it simply skips the content. It doesn't try to figure out what kinds of entities might be in there or other kinds of special XML content. It just skips over the entire section. It's defined by using an opening angle bracket followed by an exclamation point, followed by an opening bracket, a square bracket, the word C data, another opening square bracket, and then ends with 2 square brackets and a closing angle bracket. It's typically used to contain unescaped textual data. It's not parsed, so special characters like an ampersand and other brackets are legal within there. And so why would you use this? Well, imagine you have a script section, right, inside an XML document, and inside that script I have a function. Now, this is going to cause a problem in XML, right? Because that return statement there with A is less than B contains an angle bracket. Now, this doesn't happen in HTML because the browser knows what a script tag is, and when the browser is parsing the script tag, it knows not to look for things like angle brackets and to treat them as opening tag names. But XML parsers don't know this. Remember, you can make your own tags up, and so inside a tag, if you have an illegal character, that's going to cause a problem. So the way you get around this problem is by enclosing this in a C data section. This will cause the parser to simply skip over the contents, and then you could put whatever characters you want in there. Processing instructions are a way for XML content to deliver special instructions to the XML parser. They have the form of an opening angle bracket followed by a question mark with a target name and an instruction, followed by a question mark and a closing angle bracket. Now, if you're paying attention, you might be saying to yourself, well, wait a second, that's the same format as the XML document declaration. And you're right, it is. It's pretty much the same format. The XML target name is obviously reserved because it's part of document declaration. But a processing instruction can start with a number or a letter, then be followed by digits, letters, hyphens, periods, and underscores. And the reason you do this is because you have an application that can have options, for example, set by the XML content. For example, maybe you have an application that has multiple spell checking modes, and so you might want to write a spell check mode processing instruction with some kind of instruction saying, hey, use this particular alphabet when you're doing your spell checking. It's just a way for the XML data to contain information that the parser itself can use to affect how the parsing is done. All right, let's wrap up by looking at entities. Entities are intended to help shorten and modularize XML documents, and they provide markup for characters that would otherwise be illegal in XML content. There are general entities which are replaced by a parser with a full string. So for example, ampersand copyright semicolon or ampersand author semicolon, you can define these to be a string of content that will get replaced by the parser when the XML document is parsed. There are also character entities. So for example, if you wanted to include a specific character which is not available on the keyboard in your XML data, you can do that by using an ampersand, followed by a hash symbol, and then the character's code number. Some character entities also have special names. For example, the ampersand itself is specified by ampersand, then AMP, and then semicolon, or quote characters, which are ampersand, QUOT, and then a semicolon. XML syntax is a little more strict than what you might be used to if you're used to working with HTML. So let's cover the basic rules of XML syntax here. First, XML documents must have a single root tag. They have to have one, it's required. And if you remember back to the business card example, the business card tag was the root tag in that particular document. XML documents must also be what's called well-formed. In other words, there are certain syntax rules that XML documents have to meet. The first one is that empty tags have to be closed with a slash before the closing angle bracket. Now, this is different from HTML, for example, where image tags are empty, but they don't have that trailing slash. And the reason is because the browser knows what HTML is, it knows there's a tag called image, and it knows that it's empty. XML, however, remember, you get to make up your own tags, and the program that's parsing the XML may not know what your tag is. So you have to indicate that a particular tag is empty by including that trailing slash there before the closing angle bracket. Attribute values also can't be what's called minimized. And you typically see this, for example, when you're working with select lists in HTML. On option tags, you can just simply put the word selected as an attribute with no value, and the select list will show up in the web browser with that option selected. Now in XML, again, there's no way for the XML program to know whether your attribute is standalone or not. So the way that you get around this is by putting the name of the attribute and then equal to the name of the attribute as the value. Attribute values also have to be inside of quotes, either single or double. Now in HTML, you can get away with just putting attribute equals value, but XML, that doesn't fly. You have to put the values inside quotes. And then finally, tags have to be properly nested inside of each other. In the old days, browsers let you get away with this because they could basically figure out what you meant. So for example, if you had bold and italic text, and you had an opening B tag, and then an opening I tag, but then you closed the B tag and then closed the I tag, the browser would pretty much forgive you because it could figure out what was going on. In XML, that's illegal. You have to have the tags properly nested and completely inside of each other. Proper XML syntax, which is needed to make sure that the XML parser is able to properly parse your XML file. But above and beyond that, there's also a concept of what's called valid XML documents. So let's quickly review. Suppose you have an XML parser represented by these gears. You give it an XML file, and then as long as the syntax is proper and you've correctly named your elements and you've got, attributes that are quoted and so on, then the good results come out the other side. And that's called well-formed. But there's another way to make sure that XML documents are what's called valid. You can supply a set of rules which are applied to the parsing process in addition to the well-formed checks. So for example, you can supply rules that say things like tag A is only ever allowed to incur inside of tag B, attribute X only has these values, and so on. If the XML parser parses the document correctly and the document content passes the rules, that's called valid. There are two ways to do this. The first way is called the document type definitions. The second way is called XML schema. Document type definitions are simple to use, but they're not very powerful. They give you basic ways of making sure that certain content meets basic rules. They're written using a syntax that's somewhat different than XML. It's similar, but it's not exactly the same. XML schema, on the other hand, is much more powerful and flexible than DTDs are, and they're written using XML syntax rules. We will take a look at both document type definitions and XML schema when we get to the sections on making valid XML documents. All right, let's wrap here by talking about XML namespaces and why they're used. XML namespaces have the form of the letters XML-NS and then equal to some character string. And if you've used HTML before, you've probably seen this. It usually appears on the HTML tag. Now, the character string that goes inside that XML-NS attribute just has to be unique. It's usually a URL, but it doesn't have to be. The spec says it just needs to be unique. And in fact, the XML parser doesn't even try to access whatever is at that URL. So why do you use XML namespaces? XML namespaces are used to prevent tags from different languages from conflicting with each other when you try to use them in the same XML document. Remember, X in XML stands for extensible, so I can define my own tags. Now, if I want to create an XML document that includes tags from different tag sets, there's the potential for someone using the same name for a tag that I've decided to use in my tag set. So let's take a look at an example. Suppose I have an HTML file with a table in it, right? And HTML tables have things like table rows and table cells. They're used to lay out tabular data. However, if I create an XML document and I work for, say, a furniture company, to me, a table means something completely different, right? I'd have a table, and my table definition for furniture might have a type, it's going to have a price, material, how many I have in stock. Well, if I try to use my XML table inside my HTML table, that's going to cause problems, right? The browser's going to look at that table tag and say, wait a minute, what is type? What is price? I've never seen this before. So if we want to take the XML data from the furniture table and include it in our HTML file, we need a way to make sure that the two table tags don't collide with each other. That's where XML namespaces come in. So the way that you'd solve this is you define an XML namespace for your tag set. Now here on my HTML tag, I would have the XML-NS equals, and that's the XHTML namespace. And then that's followed by another namespace definition. In this case, I've got XML-NS : and then fern for furniture. And I'm pointing that at a URL that I just made up. I have no idea whether that actually exists or not, but I'm just illustrating an example here. Now, the first XML-NS definition, the one without the colon, is called the default namespace. Any tag that doesn't have a prefix in front of it is assumed to be in the default namespace. So here in the HTML document, if there's a tag that appears in HTML and there's no prefix, then the browser will just assume that that's part of the HTML definition. So here's how you would use this. Inside my HTML, I can define my table just like I always do, right? I have my table tag, my table row, my table cell, But now, in order to include the furniture table definition, I simply put the prefix fern in front of the tags that appear in my furniture table namespace. So you can see that that matches up with the XML namespace definition I included at the top of the file. So now when the browser comes across a tag that has the fern prefix in front of it, it's going to say, okay, well, I don't know what this is, but it's a well-formed tag and it's embedded in my content, and I'll parse it, but I'm not going to try to interpret it or figure out what to do with it. XML namespaces are used so that you can combine data from separate sources without having to worry about tag name collisions.